Hi, so the example in this video is going to give you some help with a one-sample t-test. Now remember, with the one-sample t-test, you're going to have your own mean, and we're going to be comparing it to some population mean. And our hypotheses options are that your mean is going to be either greater than, less than, or equal to the population mean. So that's what we're going to test in this example. Let's say that you're a football coach, and as a football coach, you want to know if your running backs at maybe your summer camp, the 45 kids you're working with, are significantly faster than, in general, what you would find for running back. Now, I by no means am going to suggest that Ironman magazine is really the population mean, especially a form on it, but let's just use that 4.6 seconds as a potential population mean. So for the rest of this example, we're going to say that mu equals 4.60, and we're going to compare that to what we have as our sample mean. So you went through at your summer camp and you found out, you took your 45 running backs and found out how fast they could run the 40-yard dash. What you did was you found out they ran a 40-yard dash in 4.56 seconds with a standard deviation of 0.3 of a second. So we're going to compare that to our population mean of 4.60, but we don't have a sigma value. We don't have the population standard deviation. And without that, we need to estimate our standard error of the mean. So that's when we're going to calculate S sub x bar. So S sub x bar, we go through and we're going to put in our standard deviation of 0.3 of a second. We're going to divide it by the square root of our sample size, which is 45. And when you put that through the calculator and round up to 0.2 of a decimal point, two decimal points, you're going to get 0.04 seconds. And that becomes our last piece of information that we need to write our formula to find T obtained. So 0.04. So we come over here and we're going to calculate T obtained. We have a mean of 4.53. We're going to compare that to a national mean of 4.6 and divide that by our newly estimated standard error of the estimate, or S sub x bar, of 0.04. We run that through the calculator and we get a T obtained of 1.75. So we're going to hold on to that information. Now, this is what we call a point estimate. And to have a point estimate, we also need to have an interval estimate. So we're going to calculate 95% confidence intervals. So 95% confidence interval, what we need in order to do that is we need our mean, which was 4.53, and we're going to subtract or add the table T value for a 5% chance, or a alpha level of 0.05. So I looked that up in my T table, and that is a 2.01. We're going to multiply it by that standard error we calculated, which was 4.01. When you run that calculation through, we get an upper limit of our confidence interval of 4.61. When we do the subtraction, so 4.53 minus 2.01, finish off that 2, times 0.04, we get a lower limit of 4.44 seconds. So we're going to plot our 95% confidence interval on our interpretive curve as well. So our last job is to draw out our interpretive curve. I've already put your table crit, or your table T down, 2.01. Let's go ahead and draw those in, but to do that, first you need to know this is our T scale. We also need to draw in our raw scale. Remember, our raw scale starts with our population mean, 4.60, and you add and subtract your standard error of the estimate. So we're going to add and subtract 4.64, 4.68, 4.72. Now we're going to have subtracted out, so 4.56, 4.52, 4.48. And we can label in our table T's, 201. It's going to be right around that 2 level, where our table T is T crit equals 2.01. We'll put in our other T crit, equals 2.01. So that's the positive, that's the negative one. Alright, now we label our regions. In this middle region, our non-critical region, we're expecting our population mean to be equal to our own mean. In this one, we're going to expect our population mean to be less than our own mean. Here, we're going to expect our population mean to be greater than our own mean. So we've labeled our hypotheses. Now we can finally label in our T obtained. Going back, remember our T obtained was negative 1.75. So we're going to draw in right around here a T of negative 1.75, which, according to our raw scale, was our mean of 4.53. So our mean equals 4.53. See how that kind of fits into our scale? Our scale here says 4.2 is here, 4.6 is here, 4.53 falls right in the middle. There's our T obtained. We also have to add in our confidence intervals. We had a lower limit confidence interval of 4.44, so that's going to be down here. We have an upper limit of 4.61. That's going to fall right there. So 95 CI, 95 CI, 4.44, 4.61. Well, our mean does fall within our confidence intervals, so we can be confident that our mean, or as does the population mean. So since the population mean and our mean fall within the confidence interval, we can feel 95% confidence that we are supposed to reject the null hypothesis, because our T obtained also falls within our non-critical region. And so we would go on and we'd finish this off by writing up an appropriate statement of the finding and conclusion statement. Hope this example helped you out. There'll be more later this semester.